The smart-eyed Colorwise True Color Sensor is the most feature-packed color sensor available today. The Colorwise offers superior detection, advanced features and versatility, yet remains easy to use. The Tri-Tronics Colorwise sensor is unique in offering the user 3 analog outputs that expand its usefulness in solving applications. All 3 analog outputs are 0 to 5 volts DC and have 10-bit resolution. They can be used to output analog color information in one of 2 formats. These are XYZ and XYY. These names, XYZ and XYY, refer to what are called color spaces. Simply put, a color space is a way to represent or model color. Using the analog outputs in either XYZ or XYY is easy and requires only a basic understanding of the signals provided. Let's look at the XYZ type output first. From a practical perspective, think of the XYZ color space as providing an RGB type of output, with the X, Y, and Z outputs representing the red, green, and blue output signals respectively. The target color is represented in terms of the red, green, and blue components that make it up. When using the XYZ type output, it is the ratio of red to green to blue that describes a specific color. The actual magnitude of the RGB or XYZ output signals will change with the intensity of the signal returned off the target object. As the target position varies, all of the signals will rise and fall together, but should maintain their respective ratios to each other. Note that if taken to either extreme, too little signal or too much signal, then the ratios of red to green to blue will become distorted and break down. Here we see white, black, and several shades of gray in between. All are essentially spectrally the same, with equal red, green, and blue components. What varies is the intensity of the return signal. The intensity of the return signal will vary both with the brightness of the color, as well as the target's position relative to the sensor. Let's note also the effect of glare. Glare is when the sensor's own white light reflects back off the shiny surface of the target object and masks the color beneath. Notice that as we angle the card, the glare reflects off and away and is reduced. The blue component becomes more prominent. Let's take a look at a simple example using the XYZ outputs. Here we have a printed stripe with a red to green transition representing a color change in a process. This could be a chemical reaction, the application of a paint or coating, the changing color of a fluid over time, or similar application. Note that as we move from red to green, the RGB distribution shows a shift from red to green. We can use this shift to determine when the process is complete or to gauge its progress. Note it is not necessary to use all 3 outputs. If the signal change in just one output will give you the indication you need for your application. Let's now take a look at the XYY color space and its outputs. The XYY color space breaks color information into 2 parts: chromaticity and brightness. From a practical perspective, think of the chromaticity and brightness as color and intensity, respectively. The XY outputs represent the X and Y coordinates on the chromaticity graph and give an indication of color. The capital Y output gives an indication of the brightness or intensity of the return signal. Let's look at a few examples for the XYY type output, as we did with the XYZ type output. Again, we have black, white, and several shades of gray in between. All of these are spectrally the same, but have a different intensity level. We can see that for all these samples, the XY values remain relatively stable. and only the Y or intensity value varies. We can also see that as we change the distance to the target, again X and Y are stable, and only the intensity changes. Now let's consider the line color as before. Here we see that the bar graph shows the XY coordinate values of the line color. Note that as we change the distance to the target, we see that these remain essentially stable, and only the intensity bar changes. The stability of the XYY type output makes it a great choice for many applications. Let's take a look at how to apply the Colorwise XYY type analog outputs to a real application. The application is to identify each of these 6 colored caps for purposes of sortation or inspection, using the Colorwise sensor's analog outputs in XYY mode. Step 1 is always to understand the problem. In this case, to characterize the analog output data to see what the data in this application looks like. To do this, we can use a simple data collection box, card, or device that can sample and capture the values of the analog output lines in greater than 10-bit resolution. Using your data collection device, take 5 or 6 samples in different positions off each cap and store them in a file readable by Excel or other spreadsheet program. Graph the X and Y points first to see what your data looks like. Then identify the samples for each color cap. If each of these groups are distinct, as they are here, then it may not be necessary to use the capital Y or intensity output for sorting in this case. Now that we have our data, we can devise a simple and robust strategy to identify each color. Here the simplest way to do this is by dividing the 6 groups with 3 straight lines. Then by selecting 2 points on each line, we can derive its equation using a little basic algebra. Then by changing each linear equation into a linear inequality, we now have 3 tests we can use to evaluate a new data point and determine which color we have. For each linear inequality, a point on one side of the line will make the statement true. A point on the other side of the line will make the statement false. For example, if I plug in a data point from the orange group into each equation, equation 2 is true, and equation 3 is also true. So for any new data sample, if equation 2 is true, and equation 3 is also true, then the sampled cap is orange. Repeat this process for each of the 6 colors to determine the logic for each case. Program this logic into a PLC or other control of your choice, and add a trigger sensor to determine when to sample. You have achieved robust color sorting of 6 colored caps using the Tri-Tronics Colorwise analog outputs. Thank you for watching. We hope you enjoyed this video.